Hello, today let's talk about subsection, a small subsection of analytical reasoning and logical reasoning, which is sequence and series. Some people call it just a series or number series or things like that. Let's understand what the sum is all about. What happens in sequence and series is that there will be a small string of say 7 to 8 numbers which are given. You will need to find out the pattern out of these 7 or 8 numbers and figure out the 9th one or probably the 7th one or the 6th one. The moment the pattern is indicative, they'll try to stop the series there and ask you what is the next one in the series. There are certain predictable parameters of how to go about, or probably a small algorithm of how to go about with these kind of series. Just the vision of it sometimes says it's a prime number series or probably a difference series, product series, square and cube series, or sometimes it is a mixed series of a lot of things put together. I think one example at a time and understanding of that particular series is more than sufficient to get this particular topic. This does not call for extreme practice, the sequence and series, just that we need to know which are the kinds of questions there so that we can start eliminating or looking at the option, it should start striking as the pattern. That is how we'll be going ahead as far as sequence and series is concerned. The first example, if I say, is 11, 13, 17, 19, 23, it is damn visible that each of these options are prime numbers and they are going one after the other. Say the prime number after 11 is 13, after 13 is 17, after 17 is 19. So after 25, all we need is the next prime number, which is 29. That would be the answer. If I look at another series, here if I look at 5, 7, 10, 15, 22, when it started as 5 and 7, we are again forced to think whether it's a prime number series or not. The moment we look at the third number, which is 10, we need to figure out something else here. When I look at 5 and 7, the difference is 2. When I look at 7 and 10, the difference is 3. When I look at 10 and 15, the difference is 5. Between 15 and 22, it is 7. Oh, now we can see careful movement of prime numbers. First difference is 2, then it is 3, then it is 5, then it is 7. The fifth one has to be 11. 11 gets added to the last number. So the next number in this series would be 33. The first example that we saw was a clear example of a prime number. Second one had a difference of a prime number. Either which way, that prime number logic should strike us. Another one, if we see 4, 9, 25, 49, 121, a cosmetic look at all these numbers, say that these are all squares. Squares also, 4 is square of 2, 9 is 3 square, 25 is 5, 49 is 7, all of these are prime numbers again. The 5 that are given end at 121, which is 11 square. So the next prime number is 13, and so the answer has to be 169. Here, these kind of series, sometimes a square, sometimes a difference, sometimes a straight series, all of them are indicative of prime number forming the base of these kind of questions. The second one we move in is a difference series. Say for example, I say 8, 16, 24, 32. It's very clear and obvious. A child's play is the difference of an 8. So if I say 8, 16, 24, 32, 40, next has to be 48. Very easy. Let's move on. Once we know this example, we know the base, we'll try to sort the others using this base. So if I say 6, 13, 27, 55, 111, something else is working here. Say for example, from a 6 to a 13, I think the relationship can be 2x plus 1, so 6 into 2 plus 1. Then it is 27, that's helping with the fact that it is 13 into 2 plus 1. We are putting the same logic there. Now we know the logic that it is the previous number multiplied by 2 plus 1. Moving further, the last one that we had here was 111. 111 into 2, 222 plus 1, 223. Here there is a common difference kind of a logic. Third one we move in, 3, 5, 9, 15, 23. 3, 5, difference is 2. 9 and 5, difference is 4. 15 and 9, difference is 6. Oh, so the difference is subsequent even numbers. Here the series, the last one that is given is 23. The previous gap, say for example 3 and 5 was 2, 5 and 9 was 4, 9 and 15 was 6, 15 and 23 was 8. So 23 and the next one should have a difference of 10. So the answer is 33, which is the right one. Moving to the next, reasonably tricky though. It is 13, 14, 18, 27, 43. It is 13, 14, 18, 27 and 43. The difference between two successive terms is 1, 4, 9, 16, 25, indicative enough that the difference is perfect squares. So after 25, addition to the last term, we'll have 25 plus 43, 68 as the last one. Another example in the same series can just be easily made by adding some difference or subtracting some difference. Playing around with these kind of questions on a day-to-day basis without putting a dedicated effort might just make you friendlier to these questions and easier to crack. First one we saw was the prime number series. Second, we saw the difference series. Third one, a product series. Say for example, 3, 6, 18, 90, 630 ought to have some pattern. 3, then it is 6. So it is 3 2s are 6. Okay. 6 and then 18. It is 6 3s are 18. 18 and then 90. It is 18 5s are 90. Okay. So the multiplier here is the prime numbers, which is 2, 3, 5. We see the next one, 19 to 7 is 630. So we are very clear this is the pattern. With the last number given as 630, the next multiplier has to be 11. So 630 into 11, that gives me 6930. That is the product series. Another variety that we see is the square and cube series. These are visible. Sometimes cosmetically you get the answers also. Say for example 1, 4, 27, 16, 125. The alternate one that you jump, that is 1 is a cube, 27 is a cube, 125 is a cube. Similarly 4 is a square, 16 is a square. So the next one we are looking forward to is a square. When we look at the numbers, it is 1 cube, 2 square, 3 cube, 4 square, 5 cube, other has to be 6 square. So it is 36. That should give us the answer. A lot of times, a lot of such series are mixed up together, and the fifth category, which we call as the miscellaneous, comes in because of mixing prime or probably square or sometimes cube and something else. That is where it becomes a little tricky as far as the questions are concerned. Also, there's this small little variety of questions which comes up wherein the alternate number forms a series. Say for example, if I look at a particular series which is 1, 2, 9, 4, 25, 6, 49. Now what is happening is that the alternate numbers, that is 1, 9, 25, 49 are 1 square, 3 square, 5 square, 7 square. The other three numbers are 2, 4, 6. The series is so easy. The fourth one has to be 8, and that should end the series. Just that because it is put amongst complicated numbers, it makes the sum look a little bit more difficult. Otherwise, a mixed series is where more than one series is put together and there's some kind of a correlation that is coming out of it. In questions of series, before we enter these questions, we should be in a fresh mood because the pattern should be visible to us. And secondly, certain practice about the kind of questions, say squares, cubes, mixed series, prime numbers should always be at the top of our head. If reasonable thoroughness or reasonable practice is done, we are sure to crack these kind of questions. Best of luck.